Hi guys, so we'll be solving an O-level past paper question from the year 2021. The session is July-August. This is question number 9. This question is based on congruence and similarity. We'll also find the angles and the area of a segment. So let's start. In the question, they've given us a circle and some segments of this circle are shaded. The question reads A, B and C are points on the circle with center O. X is the midpoint of AB and Y is the midpoint of BC. AB is equal to BC. Show that triangle AOX is congruent to triangle BOY. Give a reason for each statement that you make. Okay, so if you look at these triangles, they're talking about this triangle over here and they're talking about this entire triangle over here. So the line AB over here is going to be the same as line BC over here. Why is that so? Because since OA, OB and OC are all radius, so that means AB and BC are going to be similar. That's the first statement that we make. We say that line AB is equal to BC as they are chords of these triangles or segments. Okay, point number 2. If you look at this, AO or OA is the same as OB, which is the same as OC. Therefore, we write AO is equal to AO is equal to BO, which is equal to CO, since they are all the radii of these of the entire circle, and these are the lengths of these two triangles. Part 3 or the third statement. So if you look at this triangle once again, or these triangles once again, OX and OY are also going to be the same, since the question says that X is the midpoint of AB and Y is the midpoint of BC. Therefore, these two are the midpoints of these two triangles. Therefore, OX and OY are also going to be the same. So OX is equal to OY as they are equal in length. Let's write another statement. So if you look at these triangles and if you look at these angles of these triangles closely, since the lengths of these triangles are all the same and the angles are supposed to be the same as well, so angle AOB or angle BOC is going to be the same, or we can also say that angle BOX or BXO is going to be 90. If this is going to be 90 and this is the shortest distance, this angle over here is going to be the same as well. Maybe it's not 90, maybe it's something else, but the angles over here are going to be the same. So what we can write is that angle BXO is equal to angle BYO. They are the same angles. So we're done with part 1. Okay, let's move on. The next part says the circle has radius 4 centimeters and AB is 7 centimeters. Calculate angle BOA. What they're saying is the radius is 4. That means this is 4, this is 4, and this is 4. And the length AB is 7. This entire thing is 7, so this is 7 as well. What they're asking us to do is to find the angle BOA. In order to find the angle BOA, what we need to do is, since we have two lengths on this side and on this side and this length as well, we're looking for this angle BOA. We use the cosine rule to find this angle. So what we write is, we write 7 square is equal to 4 square plus 4 square minus 2 times 4 times 4 times cos of angle BOA. So let's write it over here. Cos of angle BOA is supposed to be 7 square minus 4 square minus 4 square divided by negative 2 times 4 times 4. Okay, so let's see what cos BOA comes out to be. So we do 49 minus 16 and then we divide this by negative 2 times 4 times 4. Okay, the value comes out to be negative 17 over 32. Then when we find the cos inverse of this value, BOA comes out to be 122 degrees. That's our answer to this part, 122 degrees. Let's move on. The next part says calculate the shaded area. Now, in order to find the shaded area, there are a couple of things that we need to do. The first thing that we need to do is to find the area of the entire sectors. So since both the sectors are going to represent equal amount of areas, let's do it for one. So let's do this. We have the angle 122 degrees over here, and if we need the area of this entire sector, we need to do so sector area of AOB is going to be 122 over 360, because that's the angle that this represents, times 3.142. I mean, you have to multiply this by pi r square, so you do pi times the radius squared. Let's see what we get. We do 122 divided by 360 times 3.142 times 16, and we end up at 17.04 centimeters squared, I think. Yeah. And then we find the area of triangle AOB. So why do we find the area of triangle AOB? Because from the sector, if we subtract the area of this triangle, we would get the area of the shaded part over here. So how do we find the area of this triangle? We use the trigonometric area formula. So we do 1 over 2 half times 4 times 4 times sine of 122 degrees. So let's do that. 0.5 times 4 times 4 times sine 122. This gives us 6.78 centimeters squared. That's the area of triangle AOB. Now we need to find the area of segment AOB. This is the part that is shaded. So we do 17.04 minus 6.78. Let's subtract these two. 17.04 minus answer. This gives us 10.3 centimeters squared. And since there are two segments that are shaded, we multiply 10.3 by 2. When we multiply this by 2, we end up at 20. Let's say 20.6 centimeters squared. So this is our final answer. We write it over here, 20.6, and we're done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.